Hey guys, so welcome. Today we're going to tackle a grade 8, grade 9 GCSE Maths question. So this is from the Edexcel board, but it is applicable to AQA, Edexcel, any major exam board. So we're looking here at finding the equation of a tangent at a given point. So we've got this circle here, and we've got this tangent here, but we've got to find the equation of it at the point P. So P is 4, 3. So how do we do a question like this? There's a few different approaches. The easiest approach, so this is GCSE. First we need to consider the gradient here. So let's say from the origin here to the point P. So that's not perfect, but that's roughly what it looks like. What's the gradient going to be of this line? So you might think, why are we working out this gradient first? We need this gradient here, right? And it's clearly going to be negative, whereas this is going to be positive. But there's a reason for it. So the reason I'm doing this is because once I've worked this out, I can then find the perpendicular gradient. So that will give me the equation, the gradient of the tangent here. So this is going to be 4 units along, and it's going to be 3 units up. So how do we then work out the gradient? Well, it's going to be m is 3/4 here, right? 3/4. That's the gradient for this point here, from O to P. But now we need the perpendicular gradient, so I'm going to denote it as the perp m here. So that's going to be the negative reciprocal of this, so it's going to be minus 4/3. So that's the perpendicular gradient. Now we've actually done a lot of the hard work. Believe it or not, this is the hardest part of the question. Now you just need to plug this back into the equation of a straight line. So you might not have seen this before. Usually it's taught first when you come to A level. Whoops. But I'm going to quickly show it now here. So the equation of a straight line is very easy if you use this formula. So it's going to be y minus y1. It's going to be equal to m lots of x minus x1. So this is going to be the formula I'm going to use, right? And using this formula, we're now going to use this gradient given here. This is my m, and we're going to plug these coordinates in, 4, 3, and see what the equation of the tangent comes out as. So doing that, what are we going to get? So let's go back to black. So plugging this in, so my y1 is going to be 3, that's my y coordinate, so it's going to be y minus 3. It's going to be equal to minus 4/3 lots of x minus 4, that's my x coordinate. So if I simplify that, what's that going to give me? So it's going to be y minus 3 still. It's going to be equal to minus 4/3 x minus 4/3 times minus 4, so that's going to be plus 16/3. So we're actually nearly done now. To simplify here, how do we do this? Well, this is y minus 3, but we need it in the form y equals. So to get it in the form y equals, we need to just get rid of this minus 3 here. So to balance the equation, we need to add 3. So therefore, I'll do it in y underneath. This means y is going to be equal to minus 4/3x. And then we've got 16/3 plus 3. So because this is a denominator of 3, I'm going to times this by 3. So this is 9/3. So 16/3 plus 9/3. So 16/3 plus 9/3. And you'll get 25/3. 25/3. And that's it. So that's giving me plus 25/3. 25/3. Now again, there's a few ways you can denote this equation here given, and this is the reason why it says find an equation as opposed to find the equation. So unless it specifies a specific form, don't worry about how we leave it, but this is probably the nicest way to leave it as. And that's it, that's the full question wrapped up. So it's easier than it looks, and I hope that's okay.